tsunami. This was a little movie, but I don't think it got the little movie file, so it's not going to work. No, it didn't work. And this just, in order to have a tsunami, you have to have vertical displacement of the water column. So what happens in the case of Chile is that here's the downgoing plate, here's the overriding plate. This plate then, during the event, is released like this, and so you impart a vertical motion to the water above it, and then that generates an incredibly large wave. So you can imagine if you have the side-to-side motion, it doesn't do that. So you have to have a vertical component to the motion along the plate. And the other reason, along the fault, the other reason why tsunamis are so dangerous is because here we have a wind wave. You can see the wavelength is very, very short. Okay, so we all go to the beach, dive through the wave, and come out the other side in a second or so. In a tsunami, the wavelength of the wave is tens of kilometers. So you're looking at essentially a wall of water that just keeps coming for several minutes. Okay, so the crest of the wave is coming for several minutes. There's no such thing as plowing through the front of the tsunami and coming out the other side. So that's why the tsunamis are so dangerous. Okay. This just shows you a model generated by the Pacific Tsunami Warning Center that shows the intensity of the tsunami amplitude. Here's the earthquake as it radiated away from where the earthquake occurred. Here's Hawaii. So the amplitude in Hawaii was actually less than they thought it was going to be, and that's because it wasn't along this line here. All right. Now, how do we know the type of event? We know the type of earthquake that occurs because we can look at the first motion of the P&S waves, or whatever waves we want, as they come to seismometers all over the world. Okay? And the distribution of these first motions, and the first motion just means when the wave arrives, is there an up in the seismogram or is there a down in the seismogram? And this just shows you here for the strike slip event in Haiti. So now we're looking down at the map view. Here's the fault here. Here's motion along that fault. And what happens? As this piece of the fault here moves up here in this PowerPoint slide, what you're going to do is push in this direction and pull in this direction. The push corresponds to an up, and the pull corresponds to a down. And in the other direction, you do it the other way. Okay? So now you can get a global distribution of whether you have up first, which is compression, or down first, which is tension, and then you can map what that global distribution is and determine what type of fault it is. In this case, there are 4 quadrangles. Well, in every case, there are 4 areas, but they don't always match up perfectly like this. And strike slip events are easier to illustrate this for because the faults are vertical. And you can see there are 2 quadrangles of down and 2 quadrangles of up. And so you can plot this, and for those of you who are geologists, you plot it essentially on a stereo net. Everyone has stereo net. Okay. You essentially plot it on a stereo net, and the distribution of your line points on the stereo net tells you what type of earthquake you have. Okay, this just shows you seismic waves across the country from the Haiti event. Okay. So, the first motions for Haiti were strike slip. We were pretty pleased, since we know from all of the evidence that we have from geology, from GPS geodesy, and tectonic studies, that it's strike slip. So here's a map of the Caribbean plate again with North America and South America. If we hold the Caribbean plate fixed, then here is what the motion of North America is doing relative to the Caribbean. It's west-southwest, okay, it's approximately west, but it's west-southwest here. And here's the Enriquillo-Plantain Garden Fault. So we know if you have a fault oriented like this, motion like this, it should be mostly parallel to the fault, so we knew it was going to be mostly strike slip. This other arrow now here, parallel to this big arrow, and here's the fault, and you can see it's mostly strike slip, but it's not completely parallel.